Hello YouTube. Today I want to do one more time a little Bedini experiment because I was with something in my head and it has to do with the frequency and the type of transistor of a Bedini self-oscillating system. I'll draw here the simple system. This is plus 12 volts. We have a coil going to a transistor. This is the MJL 2194 something, the big one here, the one that's always used in the Bedini systems. I have a resistor here. This one is going back to a coil, which will go back to the plus like this here. This will self-oscillate if this one has the right value. Then from here, with a diode, you can charge another battery, which in this case is 9 volt, but it will go up to almost 12 volts. This is a small arcade battery, 9 volt small battery, which is at the moment at 10.8. It is already filled up. It can go up to maybe 12 volt if I start charging. Now I have a little coil here, about 100 windings of quite thick wire and some thinner wire, and in there is a little ferrite rod. Now after that I will do another transistor in there, the 2N2219, which is a high frequency transistor used in FM transmitters and so. I have a 12 volt input battery here. It's a bit of a mess, but this is my input current. Now as soon as I connect this, you see we go up to 130 milliamps and nothing happens at my battery charging. Now why is that? My rod here is not in there. If I put my rod in there completely, you will see that it starts charging. My input current is now up to 150 milliamps. This is getting a little bit warm. Now it's going up, 1091. If I go to the frequency, then you will see it's 56 kilohertz and not very stable. This is a relatively high frequency for this transistor, but I trying to fix this here. It's going loose. No, it's around 56 kilohertz. It's not very precise, but it's just to give an idea. Now it's charging up to 1096. Okay, now I'm going to stop it. I'm here about 170 milliamps in. Okay, now I'll stop it and it will go back, drop back to a little higher than where we started. Now what I'm going to do now is change this transistor, and I'm going to change it by this small thing here, the 2N2219 high frequency transistor, which is not capable of doing high voltages, maybe 50 volts or something, and no high currents and so, but it does do a high frequency, and it has a better how do you call it, the ratio of input and output. So it's well, whatever, So I'm going to put that in and see what happens. Okay, back again. Here we have the 2N2219. I'm going to connect this. The voltage on the battery which I'm charging is 10.83. No current in. I'm going to connect it, and the first thing that we see is that it is 50 milliamps in, and it's charging right away. 1089. I have to put the rod in there all the way. Yep. If I put the rod in all the way, you will see even a drop in input, and the output is increasing. Now this is interesting. It's not warming up, this transistor. Now what is the frequency we are using now? This is 61 kilohertz. This is a bit higher, but interesting thing is that I'm now charging almost the same rate as before with the other transistor, but I am using only 40 milliamps. The frequency is higher. Now I can fiddle a little with the rod. If I can get it out. And you can see if I pull it out, the charging voltage is dropping, the input current is going up. So I'm putting it back in. Immediately charge goes up. It's not easy to put it in. Okay, there we go. And now here we're going back to 40, maybe 45 milliamps. It's getting a little bit warm, transistor, but it's now at 40 milliamps. And here it's almost 11 volts. It's still rising. There you go. So, what does this tell? Maybe it's better to use some different transistors, ones that can switch much faster. Okay, it's just what I wanted to show. Thanks for watching. Okay, I have now added another resistor in series with the base, where I will probably have now something about 20 kilo ohms in the base. I'm using only 30 milliamps, and I'm not charging so very fast, but still enough. Now my frequency is probably up. Yeah, it's 122 kilohertz, and if I remove my core, I can go up to 375 kilohertz, which is quite high. I'm using then 50 milliamps, but my charge is not great. Oh, it's 1095, 96. If I put the core back in, it's going up, as you can see. And my input is almost half, 30 milliamps, which is a very nice setup for this small battery to charge. I have to say that this battery was actually dead when I started these experiments. I couldn't light a bulb with it anymore, and now it has quite some power. It's slowly charging, but here a little lamp. You can see that I can take a charge out of this battery now. This is a 12-volt bulb, but it can handle it, and it goes right up again when I remove it. It's charging again. So, interesting. So a too high frequency is not a solution, I think. What I want to do now is change this system to normally I have this situation here. Sorry for my drawing, but hope you can see this. This is like it was before, plus 12 volts. This is my charge battery, 9 volts. The base now, I want to do it like this, the original Bedini with a magnet, but now I want to start it up self-oscillating with a resistor to the base with a little switch here, so I can start it up and it will self-oscillate. See what happens. Okay, I now realize the original Bedini circuit. I had to start it up manually, but it's now using 20 milliamps. It's running at 130 kilohertz and it is charging. Actually reasonably good. 1098 at only 20 milliamps. So I remove the core. There is a less charge, a little more current. It's up to 40 milliamps. Lousy charge. If I put the core back in, it's charging better and using only 20 milliamps. Interesting. One more thing with the coil in. My frequency is 120, almost 130 kilohertz. If I now remove my rod, frequency is going up, not a little. It's 200, 300, then it's going to 500 kilohertz. If I completely remove it, it's going to the 1 megahertz. 1 megahertz, almost 1.14 megahertz. 40 milliamps. Now the charge is not so great, but you can charge it with a 1 megahertz, but it's not the best. I definitely need this rod because without it my current's going up, my charge is not so good. Now it is in, charge is better. I'm only using 20 milliamps. Okay, that's it. Okay, one more experiment. I just increased my base resistance to 20 kilohertz. It was 20 kilo ohms. It was 10 kilo ohms. Now I have an input of only 10 milliamps. My frequency when the core is in is 170 kilohertz, so it's quite fast. But with the core in, I still have quite a decent charge. Now up to 11, 1101, 1102. If I remove the core, I'm going up to 2 and 3, so 30 milliamps when I remove the core. Charging does not do a lot, so it doesn't really matter, the charging. The frequency, however, is with the core in around 170, the core out I'm going up to over 1.25 megahertz with a 40 milliamps in. So it's a factor 4. If I put my core in, I only have 1 milliamp, and if I pull it out, I have only 10 milliamps, and when I pull it out, I have 40 milliamps. Charging about the same. So I'd say maybe it's better to use a bit lower frequency and a higher input, or higher input base current, and maybe somewhere around 5k or something. I'll try that to 10k's parallel. Alright, I now made it 5k's the base. As you can see, it's quite a good charge. It's really going up fast. 11.6. It started around 11. My current in is only 30 milliamps, which is not really a lot. There we go, 1107. Frequency 90 kilohertz, 90.97 kilohertz. $11.08, so it's charging very well. I can tune it a little more. What if I pull out my core? Well, it's consuming more and it's charging less. When I pull it out completely, frequency is going up, but it's no use because my charging is down. So the best is with the core in and lower the base, but not more than using maybe 50 milliamps. I'm going to try to go even lower. That'll be interesting. Okay, the best charge I can get is still about 5 kilo ohms into the base, and it's going up to 1112 on 30 milliamps in. And the frequency, the best results are between 90 and 100 kilohertz. So it's good to know. I could try to use only half the windings. See what happens then when the frequency goes up. I'll try. Okay, I left it running for 1 or 2 minutes on the 30 milliamps, around 100 kilohertz, and it's already up to 1115. It's charging really well. The transistor is staying cold. I have 2 layers of windings. It's maybe 3 meters of wire, both, one thin and one thick. And well, I didn't expect with this relatively small transistor to be able to do this, and it's actually doing much better than with the big transistors. Interesting. Okay, I left it running for 1 or 2 minutes on the 30 milliamps, around 100 kilohertz, and it's already up to 11:15. It's charging reasonably well. The transistor is staying cold. I have 2 layers of windings. It's maybe 3 meters of wire, both, one thin and one thick. And well, I didn't expect with this relatively small transistor to be able to do this. And it's actually doing much better than with the big transistors. Interesting. Frequency is almost 500 megahertz now, which is a lot higher. And if I remove the core, I'm going to the 10 milliamps. That's really too much for this transistor, I think. So anyway, I'm going over to 1.3 megahertz. And when I insert the coil again, I'm only at 40 milliamps, but I'm at 250 kilohertz, which is quite a lot. And actually, this seems to be too much. So I think the best results are with more windings, which gives me a lower frequency.